How do you navigate ethical bias in ML algorithm choice? Imagine building a machine learning system that helps decide who gets a loan or job. If you're not careful, the system might unfairly favor some groups over others. That's why understanding how to navigate ethical bias when choosing machine learning algorithms is so important. First, you need to look at the data used to train your model. Data often reflects societal biases, like stereotypes or historical inequalities. Analyzing this data thoroughly helps you see where bias might be hiding. For example, if certain groups are underrepresented, your model might unintentionally discriminate against them. Conducting detailed data analysis, sometimes called data ethnographies, helps you understand the origins and fairness of your data. Next, involve people who will be affected by your model. This means talking to diverse communities and stakeholders to understand what fairness means in your specific case. When defining your goals, choose outcome variables carefully. For example, avoid using sensitive attributes like race or gender unless you have a clear, justified reason and proper controls. Then, use tools designed to find and reduce bias. There are software packages like FairLearn that help evaluate how different groups are impacted by your model. These tools can measure fairness metrics and suggest adjustments to your algorithms to make them more equitable. Choosing the right algorithm also matters. Some algorithms are more prone to bias because of how they process data. For example, certain models might give more weight to features that act as proxies for sensitive attributes. Carefully selecting features and avoiding biased variables helps keep your model fair. Techniques like reweighting data points or removing biased features can make a big difference. Transparency is key. Document every decision you make, from data collection to model tuning. This helps you track where bias might creep in and shows others that you are committed to fairness. Regularly validating your model and allowing users to challenge or correct decisions also keeps your system accountable. In applications like ChatGPT, DALL-E, or Midjourney, fairness involves ensuring training data is diverse and representative. This prevents outputs that reinforce stereotypes or cause harm. For workplace tools that use machine learning, designing with fairness in mind helps avoid perpetuating bias in everyday tasks. Overall, navigating ethical bias in machine learning algorithms means being careful with your data, involving diverse voices, using fairness tools, and continuously monitoring your models. This approach helps create systems that treat everyone fairly and responsibly.